There is a place in our solar system that, beneath a 20-kilometer thick layer of ice, has twice as much water as all the oceans on Earth combined. A place where hydrothermal vents have likely been spewing mineral-rich water into a lightless ocean for 4 billion years. A place that has exactly the conditions we associate with life on Earth. Of course, we're talking about Europa, the 14th largest moon in our solar system. And right now, a 6-ton probe worth $5 billion is racing there to answer a single question. Are we alone? There's just one problem. Jupiter destroys anything that dares to come near it, whether it's organic or not. My name is Serwin, and this is Mars Chronicles. Before we can understand how absurdly difficult this mission is, we need to understand why we're even flying to Europa in the first place. And the answer begins in 1979. Back then, Voyager 1 sped past Jupiter and sent back images that no scientist had expected. Europa, that small icy moon, had hardly any craters, practically none. Every other solid body in the solar system has been battered by asteroids for billions of years. The Earth has been reshaped over and over again. The moon, our moon, displays its scars without any shame. But Europa? Smooth as a billiard ball. Something had to be constantly renewing its surface. Something active, something almost alive. In 1995, the Galileo probe arrived. For 8 years, it orbited Jupiter and its moon. And its magnetometer discovered something that changed everything. When Jupiter rotated, its magnetic field wobbled. This wobbling field induces Europa's own magnetic field, and it's surprisingly strong. The only way this can work physically is with an electrically conductive layer just beneath the surface. About a 100-kilometer deep layer of salt water. In other words, an ocean. Let's take a moment to let that sink in. Beneath the ice shell of Europa, there is likely an ocean that contains twice as much water as all the seas on Earth combined. On a moon that's smaller than our own. But how can an ocean on a moon that receives only 1/4 of the sunlight we get here even be liquid? The surface temperature is minus 170 degrees Celsius. 170 Grad Celsius. Actually, that thing should be frozen to the core. The answer is tidal forces. Europa doesn't orbit Jupiter alone. It is part of a resonance with 2 other moons, Io and Ganymede. While Ganymede completes 1 orbit, Europa completes 2, and Io completes 4. This mathematical elegance has a brutal physical consequence. Europa is constantly being pulled toward Jupiter. Then away again, then toward again, and so on. The moon is stretched and squeezed like a rubber ball in your hand. If an ocean exists beneath the surface, Europa bends about 30 meters per orbit. Without an ocean, it would be only 1 meter. This friction generates heat. Enough heat to keep water liquid. And where there is liquid water for billions of years, there is, as far as we know, a chance for life. If that blows your mind as much as it does mine, then hit the like button now. Simply swipe the comment window to the left in the mobile version. A like, subscription, or a short comment also helps the channel a lot. The algorithm will decide in the next few minutes whether it will push this video further or not. And you have a say in it? Thank you, and now let's continue. Now to the actual problem. Jupiter is not only the largest planet in the solar system. It is also a cosmic high-energy machine from hell. Deep inside it, there is so much pressure that hydrogen probably exists in a metallic liquid form. This substance generates a magnetic field that is 20,000 times stronger than Earth's. If you could see this field from Earth, it would appear twice as large in the sky as the full moon. Io orbits right in the middle of this magnetic field. The solar system's most volcanically active body. Io's volcanoes constantly spew sulfur dioxide into space. And Jupiter's magnetic field traps these ionized particles and accelerates them to over 300 kilometers per second. The result is a radiation belt that destroys any electronics that go there within hours to days. By the way, we have a separate video about Io, which is linked below. If you were standing on the surface of Europa, you would absorb 5,400 millisieverts of radiation in a single day. For comparison, the annual background radiation on Earth is about 3 millisieverts. A few hours of exposure would be enough to die from acute radiation sickness. And we want to send a probe into this hell that is supposed to function for 4 years. The solution is clever and is a bit reminiscent of the strategy of an experienced boxer. He knows that he wouldn't survive a heavy blow. The trick? Get into close combat, strike quickly, and retreat before the opponent can even react. Of course, that's easier said than done, but that's exactly what Europa Clipper does. Instead of orbiting Europa, the probe orbits Jupiter itself, on a highly elongated elliptical orbit. Every 14 days, it briefly enters the radiation belt, flying at 4 kilometers per hour. It flies past Europa in seconds, collects as much data as possible, and then retreats to the safe zone for 10 days. During this quiet phase, it transmits the data to Earth and prepares for the next flyby. A total of 49 flybys. A 3-year primary mission. With each individual flyby, the probe receives as much radiation as would be produced by 1 million chest X-rays on Earth. This very concept gave the mission its name, the Clippers of the mid-19th century. In the 19th century, Clippers were fast, slender sailing ships that would slip into ports, unload at lightning speed, and disappear again before heavier competitors could even dock. Exactly the same strategy, only in space. But even this strategy isn't enough to protect the electronics. Inside the probe, there's an aluminum vault about 1 cm thick. NASA simply calls it the vault. Here are the computers, the memory, and the critical control systems. Everything else is shielded individually. The engineers had to play a precise game of Tetris. Every sensitive component was placed so that it is as well protected as possible without making the probe too heavy. Speaking of heavy, Europa Clipper, at over 6 tons, is the largest interplanetary spacecraft NASA has ever built. With its solar panels extended, it measures 30 meters from tip to tip. If you placed it at the feet of the Statue of Liberty, the panels would reach all the way up to her crown. That's not a satellite, that's a flying ship. If this journey to the stars fascinates you as much as it does me, then you should definitely check out our Ad Astra Art Astra collection. It seems to have struck a nerve. Caps, shirts and hoodies. Neatly embroidered, organic cotton, sustainably produced in the EU. Nothing loud, nothing forced, just the motto that closes every video. Take it with you. Anyone who orders with the code 26 gets 15% off their entire purchase. Here is the QR code and the link is below. And now back to our space probe. One of the most curious design decisions of the entire mission is that Europa Clipper is solar powered. That seems absurd. At Jupiter, sunlight only reaches a quarter of the intensity we have on Earth. All previous Jupiter probes, except for Juno, were powered by plutonium-238, a radioactive isotope that constantly produces heat through its decay. That's the ideal energy source for long missions to the outer solar system. Voyager 1 and 2 have been flying with this technology since 1977. Cassini used it to explore Saturn. New Horizons is still sending data from beyond Pluto using it. So why not use a plutonium battery for Europa Clipper? The answer is one of the most frustrating stories in American spaceflight. Plutonium-238 is produced as a byproduct of nuclear weapons production. With the end of the Cold War, the United States stopped production in 1988. Since then, NASA has been relying on remaining stocks and even had to purchase plutonium from Russia. It's only been about 10 years since the Oak Ridge National Laboratory started producing small amounts again, 4 grams per year. For context, the Perseverance rover on Mars needed 4.8 kilograms. At the current production rate, it would only take 1,200 years to produce that amount again. And yes, you heard that right. With the ongoing automation, production is expected to increase to 1.5 kilograms per year. But that's nowhere near enough. The limited plutonium available was reserved for Dragonfly, a drone mission that is set to explore Saturn's moon Titan starting in the mid-2030s. You'll also find a video about that linked below. So, Europa Clipper was equipped with solar panels. They're 30 meters long, and to compensate for the weak light conditions at Jupiter, they're absurdly large. Even then, they only provide about 700 watts of electrical power at Jupiter. That's about as much as an electric kettle uses, and with that, a probe the size of a bus has to operate. It works, but it's a direct consequence of a political decision from 1988, the effects of which NASA still feels today. Now let's talk about the instruments. What is Europa Clipper searching for? There are 9 scientific instruments on board, plus a gravity measurement. They fall into 2 categories in total. Remote sensing instruments that analyze light and radiation from Europa from a distance, and in situ instruments that literally inhale the moon's thin atmosphere. The magnetometers, 3 in total, are attached to an 8.5 meter long extendable carbon fiber arm. They are positioned as far away as possible from the metallic probe to avoid distorting the measurements. Their task, to precisely measure Europa's induced magnetic field and thus draw conclusions about the salinity and depth of the ocean. Completely crazy. Just absolutely wow. The radar instrument Reason can see through the ice, up to 30 kilometers deep. It operates with 2 frequencies, a long 9 MHz wave for deep penetration and a shorter 60 MHz wave for surface details. During the Mars flyby in March 2025, this instrument was tested in action for the first time. It worked perfectly. 6 GB of data in 40 minutes. That means one less worry for the engineers. Spectrometers in the infrared and ultraviolet range will analyze the surface chemistry. They are looking for salts, organic compounds, and possible geyser plumes, meaning jets of water vapor shooting out from cracks in the ice. Hubble has already seen evidence of such plumes several times. If Clipper can fly through one of them, it would be like searching for DNA in a whale's breath without touching the whale. That's exactly the plan. Mass spectrometers on board will analyze everything the probe collects along the way. Dust detectors, gas detectors, and ion detectors. If even the slightest trace of an organic compound is found in one of these samples that cannot be explained abiotically, it would be the greatest scientific discovery in human history. But Clipper is not traveling alone. The European Space Agency, ESA, has sent its own mission to the Jupiter system. JUICE, the Jupiter Icy Moons Explorer. It was launched in 2023, a year before Clipper, and will arrive in the Jupiter system 15 months after Clipper. JUICE will also do some flybys of Europa, but then it will enter a close orbit around Ganymede, the largest moon in the solar system. The scientists from both missions are already talking about coordination. When JUICE is operating inside Ganymede's magnetosphere and Clipper is outside of it, both probes can measure a phenomenon together that a single probe could never detect. For example, if a plasma burst comes from Jupiter's atmosphere, both can observe it from different perspectives. That's science that only works when done together. And now the reality check. Where exactly is Europa Clipper right now, as of May 2026? The probe is on its way back to Earth. It had its Mars flyby on March 1, 2025. It successfully completed it, tested the radar in the process, and is now on a long loop through the inner solar system. On December 3, 2026, in just over 7 months, it will fly past Earth, at an altitude of just 3,200 kilometers. That's closer than most communication satellites. This encounter gives the probe the final boost in speed it needs to reach Jupiter. Arrival at Jupiter is April 11, 2020. First Europa flybys, however, not until 2031. First high-resolution data also in 2031. That means the answer to questions that have been on our minds since Voyager 1 will probably only come in 5 years. 5 years in which a probe races through space at 35 kilometers per second. Completely alone with solar panels that, at Jupiter, generate as little electricity as a kettle consumes. What would it mean if Clipper found evidence of life? Let's be realistic. Clipper is not a mission that's searching for life. No one is going to find a Martian or a Europa election. What Clipper can do is determine habitability. Answer the question of whether Europa has the conditions for life. Water depth, salinity, ice thickness, chemical composition of the ocean, energy flows, and the availability of nutrients. If these conditions are met, then the next mission is a lander. Already under discussion. A robot that lands on the surface, drills through the ice, and takes samples from the ocean. This mission would not be realistic before the 2040s at the earliest, but it would represent the direct search for life. If life were to be found on Europa, our understanding of the universe would fundamentally change. If life arose independently on two planets in a single solar system, then life is probably everywhere in the universe. The question would then no longer be whether extraterrestrials exist, but where we will find them next, or whether they have already found us. There is a story that I have to tell at the end of this video. In the late 1990s, a NASA scientist called Arthur C. Clarke, the author of 2001, A Space Odyssey. His novel 2010, Odyssey 2, ends with a message from an extraterrestrial intelligence. All these worlds are yours except Europa. Attempt no landing there. All these worlds are yours except Europa. Attempt no landing there. During this phone call, the NASA scientist showed him the first plans for a mission to explore Europa. And Clarke, shortly before his death, gave NASA his blessing, the permission to land on Europa. This permission is now coming into effect. Europa Clipper is on its way. In 4 years, it will reach Jupiter. In 5 years, we will have the first high-resolution data from an ocean that has been slumbering beneath 20 kilometers of ice for 4 billion years. And maybe, just maybe, we'll find out that we were never alone. A big thank you goes to Pusa. Without her support, this channel would look completely different. My name is Serwan, and this was Mars Chronicles. Thank you for tuning in. Per aspera ad astra. If you were to place them at the feet of the Statue of Liberty, they would... If the panels extended to her crown. If you put them by the Statue of Liberty's feet. If you placed them at the feet of the Statue of Liberty, they would... Relax, take it easy. So, produce as little electricity as a kettle consumes. Of course, the kettle doesn't produce any electricity. You know what I mean? Oh no, leave out that sentence. That's fine. This one, the kettle doesn't produce any electricity, we've taken that out. That's a stupid sentence.